Hello, I'm Monica Wood, and I am the lab manager of the LS&A Physics Lecture Demonstration Lab here at the University of Michigan. My team and I provide physics apparatus as educational aids. We have over 1,000 demonstrations that span the entire range of physics, from mechanics to oscillations, electricity and magnetism, optics, and even some particle physics. We assist professors with their lectures and outreach groups to spark interest and to emphasize the accessibility of science. To give you an idea of the types of things we build around here, we thought that we would pull out a few of the exciting and more mysterious demos we have in our collection. 3, 2, 1. First is a cannon we use to explore Newton's laws. Our ping pong vacuum cannon takes advantage of the air pressure around us. 3, 2, 1. Using a vacuum pump, we remove the air in front of the ball, then puncture the end. The air around us rushes in behind the ball, propelling it to over 250 meters a second before it collides with the pop can on the other side. A recent demo we built shows the relative flow rate through different diameter tubes. Next is one we have dubbed the killer capacitor. By charging a set of capacitors to over 10 kilovolts, 2, 1. We can rip a can in half with the magnetic fields produced when discharged through a coil of wire. Here is another demo that showcases the stored energy in a capacitor bank. The magnetic fields produced by the coil around the nail when the capacitors are discharged will propel the projectile towards our target with great force. 3, 2, 1. Let's see that again. 3, 2, 1. Nuclear fission is demonstrated using mousetraps and ping pong balls. A demonstration we are very proud of is our elliptical magnetic superconductor track. It allows us to show the importance of field geometry and the amazing levitation properties of superconductors. Our laser tank is used to image the path light takes through various optical objects, such as lenses and mirrors. A piece of history lies here in our high-voltage pulsed generator. And always a fan favorite, the Tesla coil. Throughout the years, we have partnered with many instructors who assign projects to their students. Some of my favorite come from the physics and music class. One student built a set of speakers and used our audio spectrum analyzer to characterize the quality of sound coming from them. Another student explored the importance of the bridge shape in the placement on a violin. We provide these students with a place to work on their projects, instruct them how to properly use various tools, and we offer guidance as they construct their prototypes. We are excited to continue to offer a place for students and faculty to come and bring their ideas to life and hopes to make science accessible to as many people as possible. Thank you.